Good morning, good afternoon, good evening. Please, 2 minutes. Lussac law that expresses the relationship between pressure and temperature. The relationship between pressure and temperature is direct, meaning that the more pressure you apply to something, meaning a globe, something like that with a gas, the more pressure, the less volume, the less space, so the particles of gas there bump into each other more, meaning more temperature, okay? The temperature is a measurement of the speed of the molecules in a gas, so if you have less space, if they're moving, they bump into each other more, there are more kinetic energy, so there is more temperature, okay? More pressure, more temperature. You can take the P2, the final pressure for there, with this formula, and you have to know that all the temperatures must be in Kelvin. To do that, you add 273, okay? Here you have one example. First, you add 273 to the temperature, and then you apply the formula. Initial pressure times final temperature divided by initial temperature, okay? Just use the calculator and can do one of them. So you add 273 to the temperature, so 0 degrees centigrade is 273, and to add 1000, you have 1273. Then you write here the initial pressure, that is 20 atmospheres. Now we are at 1 atmosphere, okay? And then 1273, take your calculator and you do 20 times 1273 divided by 273. That is 93.26 atmospheres. So as you can see, as you get more temperature, you get more pressure. Okay? And the inverse exercise is to get the final temperature if you change the pressure. Okay? Like I said, as you get more pressure, you get more temperature. Here you have one example. If you get up the pressure by 1 atmosphere, you rise the temperature. Okay? One example. Yeah, initial temperature, final pressure, initial pressure. Okay? Now we are getting down the pressure, so the temperature should be less. Okay? As you can see, the temperature goes down as you lower down the pressure. Okay? And that's all.